Hey, hello, welcome back to this video of OpenFOAM. Um, let's see. Last video we talked about templated classes. All right, but I mean, unfortunately, that's not enough to quite satiate what we need to know in order to roughly understand this code. Okay, you'll see that templates don't just work for classes; they don't just work for functions. They work for classes as well. So you can see template class type, class FV matrix. So this is a whole template for a class type. And not only that, you will see here there are templates within templates. Okay, so this is a template for the class type, and within the class type there are also functions. See, for example, here in the protected section, there are member functions of this. So you can have two templates, one within another. So the first one will use the thing class type. Second will use something like this type 2. Okay, so all of these are function declarations in the templates. So we'll need to at least acquaint ourselves, familiarize ourselves with using templates, because OpenFoam Code does use that. So if you want to read the OpenFOAM source code, you will need to understand what templates are. And just remember again, this class here is not the same as this class here. Okay, so next thing, you may want to know also, not just about class types and templates, but also inheritance. Now, if you're familiar with C++, you can just skip a few videos ahead, no problem. But yeah, I will want to go through some of these features of the C++ code which are used in fvmatrix.h. Okay, or at least the fvmatrix class. All right, so without further ado, let's begin. Okay, let's begin. So let me minimize this and okay, yes, that's what I want. All right, so let's talk. Let's start with a class. Okay, class types. Okay, so vim template demo.h, and if you want to take a look, you can look at the same Geek for Geeks file. We have actually a template for functions. Remember, this word type name is interchangeable with the word class. And because OpenFOAM uses the word class, I will stick with the OpenFOAM format and I'll not use the type name here, just to be very consistent. Okay, so this you can see here another template is here. You can these are class templates. Okay, these are class templates. Okay, so like function templates, class templates are useful when the class defines something that's independent of the data type. Okay, for example, well, you see your FV matrix class here is it can take in scalars, it can take in vectors, etc., etc. Because you will see here FV matrices forward.h, you can see the templated classes being called. Okay, so in fact, this is a type definition. This is another thing altogether, but you can see the template syntax is being used here because we have this type thingy. Okay. All right. So yes. What this is saying is that when FV scalar matrix is called, you will take FV matrix and you put the scalar as your data type. So the data types here are scalar, you have vectors, you have spherical tensors, symmetric tensor, and normal tensors. Okay, so there are lots of data types here. Of course, there are specialized versions of actual data types, but that's another story for another time. Okay, so let's talk about templated classes and how we can like use them. So this is a templated function which can represent any of this. Okay, so let's see. Okay, templated class syntax here. Okay, class syntax. I'm writing it down somewhere just to take note, of what I'm saying. Okay, let's first take a look here how we define classes. So you start with this thing class, and then you open brace and close brace here. Okay, again, class, class, open brace and close brace with a semicolon. Remember, there's a semicolon behind the class, not for functions. So now let's take a look at FV matrices, and let's see how they format their class declarations. Okay, so if you take a look here, you see the template. They have this template. This is how you start your template, just like for functions. Then the class FV matrix is declared here by declaring, okay, class FV matrix. Then these two things here are inheritance, which I'll not go through yet. But you notice that the curly brace here is not found next to this FV matrix here. You will have it below. So this is how OpenFOAM likes to standardize its code. And remember, every indentation in, it's 4 spaces here. This is actually 2 times 4 spaces or 8 spaces in. Okay, every time you go one level down. So it's a very, very neat code. And every time you have you go between 2 templates of classes, you see, or functions, you have one function here, and then you have a space, and then you have another function here, and then another space. So this way it makes sure everything is nice and readable. Okay, so again, the thing about OpenFOAM code is that you have to open curly brace at the next line rather than on the same line as where you define your class. To C++, it doesn't make a difference, but to human readers, it makes a big difference in terms of neatness. So again, you can see your open and close braces are on separate lines. You don't put your open brace here. Okay, so enough of the formatting stuff. Let's go back to classes. So class FV matrix, open curly brace, and the close curly brace is somewhere all the way down. Okay, all the way down. Okay, it's a very, very long class, as you can see. This is the close curly brace and the semicolon. So let's just follow this style of writing to make sure we are very neat. Okay, so I'm going to put my class template here. Okay, template class. Then I can put type here as well. Okay, so what do I need to do? I can define a new class, and I'll just call it a print class. Okay, not very creative, but okay, that's what we have. And one open curly brace, one closed curly brace, and the bracket. Remember, the open and closed curly braces are here, and this is how things are defined in OpenFOAM. So you can take a look more at the styling guide, but I'll just demonstrate it for you. Okay. Next thing, what do you need to do? If we check the FV matrices for the way they operate, okay, we see that the class access modifiers, okay, it's first private, then protected, then public. Okay, private, protected, and public, and always make sure there's a line here. See? Okay, so this is a private data. Okay, so all your private data is here. The protected data and functions are here, and the public data and functions are here. Okay, so let's put that down. I know it's tedious, but it will pay off later on when you want to read your own code. So if I'm not wrong, you should put private here. Okay, and make sure you leave a line. Protected and public. Now I'm not 100% following them on the OpenFOAM way of doing things, but the way I want to do it, I'll try to follow as close as possible so that you don't have to edit so much later on. Okay, what's next? Okay, so these are access specifiers. Just a bit of revision for you if you cannot remember, or in case it's your first time. Public classes, okay, or public functions and data. These are functions and data you can call anytime when you declare an object. Okay, protected, private is the other extreme. That means if you declare an object in your sandbox.c file, if you declare an object over here using this print class, I will not be able to access any of the functions under the private. Okay, under the private section, I will not be able to access any functions. I will not be able to access any pieces of data here. Okay, protected is somewhere in between, which means that only special functions and can actually access or special groups of functions within the so-called same family or what. They can access this protected part. But I'll not go through so much into this, but that's basically the long and short of it. All right, how much time am I going? All right, 10 minutes in. Okay. So next thing, let's make a constructor and destructor. Okay, so let me see how much time am I yapping along. 11 minutes, yeah. Constructors and destructor. Okay, constructor and destructor. Let's make a constructor and destructor. How are they being declared? Okay, so you can follow the template here. Okay, so you see constructors are here in public and destructors are here also in public. Make sure you comment these things correctly. Okay, make sure you comment these things correctly. And member functions are one indentation level in. So okay, let's type it out. Okay, leave one space. Okay, you can see they actually leave spaces between the public, and then you leave a space, then you have constructors, then you leave another space. Okay, so constructor is one indentation in, and it's one indentation in, and then the member functions are another indentation in. So yeah, pardon the many the ways we do it. So okay, let's do it. And you can put over here, okay, constructors. Okay, 4 spaces, 1, 2, 3, 4. Constructor with capital letter C. Okay, where's the constructor? Yeah, constructors with capital letter C, 4 indentations in. Then we can 4 spaces in. Then 1 space. Okay, 1, 2, 3, 4. Okay, and 1, 2, 3, 4. So this is 8 spaces in or 2 indentations in. So we can make our first constructor. It's very tedious. I know. So this is we can make this constructor and we'll just call it the empty constructor because we are not giving in any data type. And for functions like constructors, okay, remember, just to refresh your memory, constructors are functions that automatically are run once you declare the object. Okay, so again, 8 spaces in and 1, 2, 3, 4 info. Okay, so I'm just going to make a constructor that says, okay, constructor declare. Okay, and then end line. Okay, so this is the basic structure of a class with one constructor. Okay, I paid a lot of attention. To formatting. Well, but you can see it's very painful to do, especially to explain all the formatting. And maybe on your end to hear all the formatting as well, maybe a bit painful and long-winded, but I can assure you, as we go along, it pays off. You see, this thing is a very neat. Okay, a very neat code. So okay, so print class constructor declare. Okay, so let's test whether this is working, and let's declare a class. Declare an object. So how do we declare objects? Okay, we will say print class, okay, the class first, and then we'll just say object1. Okay, and that's declaring object1 as an instance of the type print class. All we should see is this thing here that says constructor declared. Okay, so I'm gonna save and quit, or not, just save. Okay, save, and as far as possible, no trailing white spaces here as well. Okay, so no trailing white spaces, but make sure you have your close curly brace and semicolon. Okay, so close. Yeah, I'm not sure if I get the things right, but at least, you know, it's neat. Okay, let's do wmake. Okay, missing template arguments. Yes, okay. So remember, we are supposed to, I forgot about the template arguments part. Okay, remember, this class is not just any class, it's a templated class or class template. So when I declare an object of the type print class, okay, I'm supposed to give the arguments here. Okay, I'm supposed to give the input. What kind of class do I want? So I want the data type to be integer. Okay, so I need to put in the integer data type here. Okay, wmake. Okay. Missing templates argument. Oh, before object1. Okay, my bad. I think you have to put it here. Int. All right. I think that's how you declare objects properly. Okay, wmake. Now try and error. It's what coding is like. All right. Now things are working well. Let's run sandbox 2. You see, constructor declared. So this is basically how we can do a template class. Okay. Now we can actually do more than one constructor because this first constructor here was given with no inputs, right? So if I want a constructor with an input, okay, I can put this print class. Then I will say I want one input type data. Okay, for example, and then of course the curly brace should be on the next line because there's literally, I mean, here we will have many lines of code, so we don't want to mess ourselves up. 6, 7, 8. 1, 2, 3, 4. Okay. And what's next? Next, info. I can say constructor declared, but I'm not going to do that. I can say you gave me data of type. Then I can use the type ID command. Okay. And line. I can use the type ID. Info. Type ID name, right? Type ID name. Type ID dot name or type ID data dot name. Okay, so this is the data type. It could be any data type, right? So it's a integer, and so we should expect I here. Okay, so let's go to sandbox. So we save this here with :w vim sandbox2.c. Let's give it well, let's give it A. Okay, because A here is a float. Okay, 2.23. A here is a float. So as soon as you start, you declare this object, you pass in a float data type into object1, you should be able to have this constructor activate instead of this constructor. Okay, because let me see how much time. Yeah, because you passed in a piece of data. So depending on how many data, you can actually define one constructor for depending on how many data types you go in, you put in. Okay, so yeah, so this is just an example function which is able to take in some pieces of data as soon as you declare the object. Okay, so to call this templated class, you just say print class and then you give the type integer. And oh, maybe I should put the argument here. I should give the input over here. Yeah, if I'm not wrong, okay? I have to go and double check. I'm a bit rusty on this, but yeah. Let's do wmake. Okay, so doesn't look good. Right, let's see. Okay, let me try giving this instead. I'll put the A here. Okay. Okay, all right, so that's the correct way. The A should be at the object one rather than at the print class. Okay, so that's just something to take note of. When you have your classes, you should do the data type at the print class rather than at the object. But when you pass in data into this class, you should declare it at the object. Okay, that's that. Okay. Whew. Yeah. Okay, so that's that. Now I'm not going to go into the type type within type kind of thing yet in this video. It will take a bit long, so I think I'll just stop for now. But yeah, just to review what we went through in this video, we went through how to declare do class templates. Okay, and we also do it in the OpenFOAM formatting way. It is very tedious, I admit, but it's good to do because it gives you very neat code and it's standardized with the standard OpenFOAM syntax and way of coding. Okay, let me undo that. Yeah. Okay, let's save and quit. Wmake. Yeah, so we actually made two constructors. Okay, and then it says you gave me data of type integer. Okay, so that's the second constructor being activated instead of the first one. Okay, just sandbox2.c and all right, I mean just yeah, print class int object 2. Okay, wmake okay. Yeah, you can see I have one constructor that says you give me data of type, and when I didn't pass anything into the object, it just gave me a null constructor and it just says constructor declared. Okay, nothing too special here. Okay, so that's all I have. I know it's quite a lot and very tedious with the OpenFOAM way of coding. Okay, but yeah, it will do you good in the long run if you learn this properly. Okay, thanks for watching. I'll see you guys again. Bye-bye.